Hello, in this video, we're finishing up section 6.2, and it's really all about word problems, but there are three types. Finding the probabilities for a random variable x. It could be the price of a car. It could be a cholesterol reading for a particular patient. It could take the form of a lot of different things. The second type is finding the probabilities for the mean of a sample, that's x bar, and that involves what is called the standard error of the mean. So it's going to be a new formula. And the last type of question is where they ask you to find the sample size based on that standard error of the mean. So let's start out with finding probabilities for a random variable x. In general, this involves that we transform x into a z-score with this formula. And I would recommend that you use the calculator to actually find your areas under the curve, because tables are not provided in this exercises. So remember that the area under the curve is actually equal to the probability of a z-score. And on the calculator, that involves using the distribution menu, and you access that by second bars. Let me get my pen. Second bars will get you the distribution menu, and in particular, we're interested in using option 2. So let's look at an example, and let me go ahead and make this larger now. So it says the average cost of a luxury car on a large lot is $55,580. Suppose the distribution is normal with a standard deviation equal to 7,300. So right there, they're giving you the population mean is the 55,580. They're giving you the population standard deviation of 7,300. And now this is what they're asking you. Find the probability that a randomly selected car costs less than 54,631. So we write that as the probability that X is actually less than 54,000. Well, hold on. 54,631. However, in order to answer this, we have to change this x. X equals 54,631. We have to change it into a z-score. So we use the formula that we've learned for the z-score earlier in this chapter. So we have z equals, and then we have x minus mu divided by sigma. The x value, random variable x, minus the population standard, the population mean divided by the population standard deviation. So that will be 54,600 631 minus mu, which is 55,580. And see, your x is under the mean, so this is going to turn out to be a negative z-score. And then divided by 7,300. So I'm going to take 5,463. actually 54,631 minus the mean, and that is 55,580. Subtract, and then divide by the population standard deviation, which is 7,300. So the z-score is a negative 0.13. So what this means is that we want to find the probability that the z-score is less than negative 0.13. And even if we did this problem live, it does not give you the tables. So that's why I recommend that you actually use the calculator. So first of all, let's think about what this means. We know that negative z-scores are to the left of the mean. The mean is right here in the middle, and that's when the z-score is a 0, where the mean is. And I'm going to exaggerate this. I'm not really drawing it to scale. I just want to be able to see it. So let's say that a z-score of negative 0.13 is here. So we want the probability that the z-score is less than that negative 0.13. So we want this area here. So when we're using option 2 on the calculator, we need to think about a lower limit and an upper limit for this area. So my lower limit is negative infinity, and this is actually my upper limit. But instead of using negative infinity, we use negative, and I prefer putting 6 nines instead of a negative a million, but I'm just putting a very, very small number there. So let's go to that option 2 of the calculator, which is the normal cumulative probability distribution. I think I have too many letters in here. Let's look at the calculator. So I go second bars, and it's option 2, so it should be CDF is number 2. Let me fix that first. It does not have a P, but it's option 2. So this option 2 is always asking you for a lower limit and an upper limit. So remember, our lower limit is a negative infinity, so I put a negative and 6 nines. I put an extra 9, it doesn't matter. You just want a very small number. Now for my upper limit, I put the z-score that I found, which is the negative 0.13. Now, this shouldn't change if you're just starting to work on the calculator. Like if it's been turned off, it should not be changing at all. But for the normal distributions, mu should be 0, sigma should be 1. And so we go down to paste. It will reset if you were using something else. Press enter. And this will be the probability. And let's see if it gives us any instructions on how to round it. So it says give your final answer as a percent rounded to 2 decimal places. So when I first get this answer on the calculator, this is not a percent. So I'm going to take 5 decimal places. So that would be 0.44824. Then you're going to change it into a percent. So that will be 44.824%. And it says to round your answer, to give the final answer rounded to 2 decimal places. So that would mean we want to put 44.82, and I cannot round it up, but that would be your percent. Now, let me make this a little bit smaller so you can see the problem as well as the rationale behind it. Okay, let's look at another example, and let me make it larger now so we can read the problem. So it says the mean bicarbonate concentration in a normal person's blood is 120 milligrams per deciliters. So it says the mean. So that means that this is going to be my mu. The population mean is 120. Suppose that the distribution is normal with a standard deviation equal to 5.4 milligrams per deciliter. So that's giving you the population standard deviation, sigma, is 5.4. Now here's the question. If an individual is randomly selected, that means you're looking at an X value. Find the probability that the individual's bicarbonate concentration will be between 120 and 121.5. So we are looking for the probability that X is between 120 and 121.5. So we really have two X scores to change to Z scores. So I'm going to take Z and I'm going to take 120 minus the population mean, that's 120. Oh, so that should turn out to be a 0. Because it's equal to the mean. So then for 121.5, I'm going to have 121.5 minus mu, which is 120, divided by the population standard deviation, which is 5.4, and that will be 1.5 divided by 5.4. And that's going to give us a positive Z-score. And usually the Z-scores are rounded to 2 decimal places. That's what we normally see on the tables. So I'm going to take 0.228. However, I've noticed some slight errors in Sophia. If they don't give you instructions for any intermediate answers, I would go maybe one more digit than necessary. So I would say 2.77 without rounding it. It's not your final answer. Since it says give your answer, actually, hold on a second. It says use a normal distribution table to find the area, but it's not provided. To find the area to 4 decimal places, and then give the percent to 2 decimal places, but they don't say anything about the Z-scores. So the Z-scores on the table will have only 2 digits. So I think we're okay with 2.27 in here, but I'm gonna actually do it on the calculator. So let's do it as if we were doing it on the table. So then that will be 0.28. Okay, so now that probability becomes the probability that a Z-score is between 0 and 0.28. And since the tables are not given directly in these problems, that's why I prefer to actually think about using the calculator and think about the population, the area under the curve. So this is the mean, and that's where the z-score is 0. And I'm exaggerating this, but a z-score of 0.28 will be here. So the area between them will be this area here. So then this will be my lower, and this will be my upper when I use that option 2 of the calculator. So I'm gonna go to the calculator. So I go second vars, option 2, and the lower is 0, and the upper is that 0.28. Press enter, enter, until you go to the word paste, press enter again. And that gives us 0.1102. So this is when you're getting the area and they ask you to give the final answer to 2 decimal places, but the area actually is that probability that we're getting. So I have here 4 decimal places, so that would be 0.1103. Then when you change it into a percent, it will be 11.03, 11.03%. So it's already rounded to 2 decimal places. So this will be the answer here, 11.03. Now, let me make this a little bit smaller now so you see the whole problem. As well as the work. Okay, so the second part of this section is actually finding probabilities for the mean of a sample. It's not for a particular X value, a particular random variable like the price of a car, or like I mentioned, the cholesterol level. Now it's talking about the mean of the sample. So we actually have this new formula that is an adjustment for the standard deviation of the population based on the mean, and it takes actually the population standard deviation sigma divided by the square root of the sample size n. And this is called many times that sigma sub x bar is actually many times called the standard error for the mean. So we have to adjust the population standard deviation in this way, and then we convert the sample mean x bar to a z-score. And I need to make a correction here. This should not be just sigma. This should be the sigma x bar that we just adjusted. And then we find the probability for that particular z-score. So it's how you find the z-score. Notice that you don't have x, but you have x bar minus mu this time. And instead of divided by the standard deviation, you actually are dividing by this adjusted standard deviation that we call the standard error of the mean. So let's look at an example. And you will see how it's worded a little bit differently. It says a survey was conducted and it was reported that boys between ages 12 and 15 play an average of 17 hours of video games per week. Okay, so that is the population standard deviation, the population mean, 17 hours. Assume the variable is normally distributed and the standard deviation is 2 hours. So that is sigma, which is the population standard deviation, that's 2 hours. But notice this is different. It says, if 18 boys between ages 12 and 15 are randomly selected, find the probability that the mean of the number of hours they play, it's greater than 18.3. It says the probability that the mean is compared to a certain value. So another piece of information that we're given is that the sample size has 18 boys. Then we're looking for the probability that the mean of that sample, so that's X bar, is actually greater than 18.3. So to find the z-score, we need to make certain adjustments. So the first adjustment is to find that standard of error of the mean, which adjusts the population standard deviation, and is sigma divided by the square root of n, the sample size. So that will be this population standard deviation divided by the square root of the sample size. So I have 2 divided by the square root of 18. And it's not my final answer, and it's really a long string of decimals here. So let me think about what I will do. It says to round your answer, the final answer, to 2 decimal places, but that's a percent. So when you're looking for an area, you want to look at 4 decimal places. So let's take for this adjusted standard deviation, the standard of error, let's take 6 decimal places. So I have 0.471404. Okay, so now to the z-score, but the formula for the z-score has changed. It's not x, but x bar minus mu, the sample mean minus the population mean, divided by this adjusted population mean, that of standard error of the mean that we have. So X bar will actually be 18.3 minus mu, which is 17, then divided by that 0.471404. And if you wanted to, since we're doing this on the calculator, you could say in parentheses 18.3 minus 17, close the parentheses, divided by the answer from the previous step. So you can say second and the A and S, and that way you don't have to worry about rounding or only selecting 6 decimal places. Press enter, and this will give you your z-score. But let's do round the z-score to 2 decimal places. So that will be 2.76. Okay, so then this probability becomes the probability that the z-score it's greater than 2.76. So again, I think about this as the area under the curve. Here is a z equals 0. I'm not drawing this to scale because I want to be able to see the difference here. So here's the z-score of 2.73 or 76. So this time I want the area where the z-score is less than that 2.76 or greater than. So it will be this area here. So then this will be my lower limit. And my upper limit is actually positive infinity. And that's at 99, 6 nines instead. So now I'm going to go to option 2 of the calculator. So that will give me 2.73. And my upper will be a positive infinity. So I put 6 or 7 nines or 5 nines. Just make it something really, really big. And I made a mistake there. This should be 2.76. Now press enter, enter, enter again. So this is the area under the curve. So we typically take 4 decimal places for that. And if we round it up, that will be 0.0029. Now, when we change it into a percent, that will be 0.29%. Very low probability. Okay, so let's look at another example. Says, suppose that the average age of a specific type of industrial manufacturing machine is 8 years. So it says average age, so that's going to be mu. The population mean is 8 years, or 96 months. And it looks like later on they're talking about months, so we're going to actually use 96 months. Then it says, assume the standard deviation is 19 months, so that will be sigma. If a random sample of 32 machines, that means n equals 32, is selected, find the probability that the mean age is between 90 and 100. So it's asking you find the probability that your X bar is between 90. X bar is your sample mean, the mean of the sample. So that's 90 is less than X bar is less than 100. So that means I need to find a z-score for an X bar of 90, and I need to find a z-score for an X bar of 100. Now, remember that your formula has been adjusted. The formula for the z-score is adjusted, so we may have to find this adjusted standard deviation or standard error of the mean first. So that would be 19 divided by the square root of 32. And this is not my final answer, so I'm gonna write down 4 decimal places, but I'm gonna use that whole decimal on my calculations. So it's 3.3587. I'm gonna put this in a little box because it's kind of getting cramped in here. Okay, so now going back to find the z-scores, it should be, remember, the x bar minus mu divided by that standard error of the mean. So my x bar is 90, my mu is 96, divided by this 3.33587. So 90 minus 96 is actually a -6. So what I'm going to do is I'm going to take -6 divided by the answer from the previous step. So I go second and the negative sign. And this is a z-score, and we usually use, when we're using tables, we use only 2 decimal places for the z-scores. So I'm going to change this to -1.79. Okay, now I'm going to set this one up. So I have a z-score equals x bar, which is 100, minus the mean, which is 96. This one is going to be positive, divided by the 3.3587. So that's going to give you actually a 4 divided by the 3.3587. So I take 4 divided by, and if you want to just recall this whole number like we did with the previous calculation, you can move your cursor here, press enter, and it will bring that whole decimal. Now press enter, and then this is your z-score, and we rounded it to 2 decimal places, which would be 1.19. So then this probability changes to a probability based on the z-scores. The z-score will have to be between -1.79 and 1 point, and I meant to put less than. And so we can draw a picture here if necessary, but we can also just assume this is my lower limit. This is my upper limit in that option too. So then I go to the calculator, second bars, option 2. So my lower limit is the -1.79. Press enter. My upper is actually positive 1.19. Press enter, enter, go down to paste, press enter again. And this gives you your area under the curve. And we take 4 decimal places. That will be 0.8462. And when I change it into a percent, it will be 84.62. And even if I took 5 decimal places here, I would not have been able to round the 2 up, because it would have been followed by a 4 here. Okay, let's look at question 3, and they're the same type. We're looking for a probability for the mean of a sample. So we have here the average number of gallons of soda that a person consumes a year is 42.5 gallons. So that would be mu. Assume that the standard deviation is 7 gallons. So that would be the population standard deviation is 7 gallons. And that the distribution is approximately normal. This is what allows us to use the tables, and as well as that option 2 is a normal distribution. If a sample of 10 individuals is randomly selected, so we have n equals 10, find the probability that the mean of the sample will be less than 44 gallons. So we want to find the probability that X bar, the mean of the sample, is less than 44. But before we can do anything here and find a z-score, I need to adjust the mean with that standard error of the mean, where you take the standard deviation, population standard deviation divided by the sample size. So we take 7 divided by the square root of 10. And let me clear all of this as well as my keystrokes. So I have 7 divided by the square root of 10. And that is 2.2135. I don't like rounding it, but I do want to write it down in here. So I'm going to take 4 decimal places. Instead of really rounding it, I actually tried to use the calculator to bring down the whole value that I have there. Okay, so now we're going to change this X bar of 44. We're going to change it to a z-score, and the formula will be X bar minus the population mean divided by the adjusted standard deviation, that standard error of the mean. So then I have X bar is actually 44. We're comparing it to 44 minus mu, which is 42.5, divided by that 2.2135. But what I'm going to do, let me write that down again. But what I'm going to do is, instead of rounding that, what I'm going to do is I'm going to put in parentheses 44 minus 42.5, close the parentheses, divided by this answer here, second, and the negative sign, divided, and then that way I'm not rounding it. Now, this is a z-score, and typically our z-scores are given to 2 decimal places, so that would be 0.67, 0.68 when I round it up. So then this probability becomes the probability that X is less than 0.68. So when you think about, and sorry, not X, but Z. So when you think about the graph, here is Z. I'm going to exaggerate this. A Z-score of 0.68 is to the right of the mean. I meant to put that this is equal to 0. So if it says that you want the Z, you want the probability that Z is less than 0.68, then I want this whole area here. That's where the Z's are less than. So then my lower limit will be a negative infinity. My upper limit will be this Z-score. And now we can go to option 2 of the calculator. So I have second vars, option 2, and my lower limit is negative infinity. So I put a negative and at least 6 nines. Then my upper limit is the Z-score that we found, and that was 0.68 when I rounded it up. Yes. So now we go down to paste, press enter again. And this is the area under the curve. We usually take 4 decimal places for that. So that would be 0.7517. But then when we're talking about probabilities, we express that as a percent. So then that will be 75.17%. Now, let me make it a little bit smaller so that you can see the whole problem in what I wrote. Now, the last type of exercise, there's actually only one question related to this, and it's a bit kind of worded strangely, so I thought it would be good for us to look at it. So here, they're talking about the standard of error in relation to finding the sample size. So if they ask you to find the sample size, see, it says the standard deviation of a variable is 14. The sample is 400 individuals. Compute the standard error of the mean. And then it says what sample size is needed to cut this standard error of the mean in half. So first of all, I want to remind you that the standard error is this formula that we have been using to adjust our standard deviation, a population standard deviation. So this is what they call the standard error of the mean, is this little formula here. And it takes the population standard deviation sigma divided by the square root of the sample size. So in this problem, they actually ask you to find the standard error of the mean first. And they give you that the standard deviation is 14. So that means sigma is 14. The sample has 400 individuals. So that means n equals 400. And that's what you need to find that standard error of the mean. That sigma sub x bar, because it takes the population standard deviation divided by the square root of the sample. So we're taking 14 divided by the square root of 400. And that's going to come out to be a nice exact value, at least not a repeating decimal, because the square root of 400 is actually 20. So when I divide 14 by 20, I get 0.7. So that will be your first answer here. The standard error of the mean is 0.7. Now, this is the part that is a bit interesting because it says what sample size is needed to cut the error, the standard error in half. So they're asking you, when they say sample size, they mean n. What should n mean? What should n be so that your sample size, what is your sample size so that the standard error is cut in half? So remember, the standard error, we found that is 0.7. So if we cut it in half, we're saying that we want that standard error to be 0.35. So now we want to use this formula again. And looks really like a 6 there. And I don't mean to write it as a 6, but we use this formula again. But this time we want this to be 0.35. The standard deviation hasn't changed. That was 14. And we're looking for the sample size. So it does become a little bit of an algebra problem because we multiply both sides by the square root of n. So you have 0.35 square root of n equals 14. Then we're going to divide both sides by 0.35. So that will be 14 divided by 0.35. And that turns out to be 40. And now to get rid of the square root, we square both sides. So that's going to give you just an n. And 40 squared will be 1,600. $1,600. So in order for the error to be cut in half, the sample size n should be 1,600. So this was the last problem that I had planned for this section. So let me go ahead and make this a little bit smaller so you see the problem as well as the work we did. So good luck with your assignment.